for starting the recording. So, hi everyone. So, my name is Sandesh and I live in California. So, we have started our company named Wasp Software Systems Software Services Private Limited in India, and MATSUND Learning is a tech learning division for our company. And we are. Let me start my camera. Okay, yeah. I hope you guys can see me. So, Muscle Learning is a tech learning division, and our aim is to improve quality education to people. And ultimately, uh, our aim is to, for the deserving candidates, offer internship, and then if internship goes well, then maybe employment in our company. So that's the whole idea behind starting a tech learning division along with the software services company. So we can talk more about at the end of this presentation. And so let's dive into the technical concepts, what we want to cover in this session. So this session is to give you the idea that what you can expect from machine learning if you join our courses, or let's say join our any Python course, or enroll for any course, how what you can expect. So this session is designed to give you idea that how you can how w- idea that how much we know, so that you can trust us with this course. And this covers some bits of fundamentals, and then in the towards the end of the we will cover one particular program of Python to give an idea that how we will be teaching programming concepts. And so we in at the machine learning we like to connect the dots, starting from bits and bytes to the program. So all the this whole session is structured to connect from bits and bytes all the way to the program. The program is for shallow copy and deep copy of in the Python. So we want to show you how bits and how can really connect from bits and bytes to that program. So Pradyuman, can you go to the next slide, please? So this session we'll start from bits and bytes, then we'll talk about little bit about how this what is inside your system unit of a computer, inside the laptop, what do we have, and that way, and give you idea that like different components, where they reside, and how they, because the idea, if you have idea of what is inside your box, inside your system, it will give you more deeper understanding when you're actually learning programming. So our aim is to give deeper knowledge, which ultimately prepare you for a career in the software industry, right? So that's why you have to have little bit deeper knowledge than just learning the programming concept. So this is how we structure. We'll tell you bits and bytes, what is in your CPU box, CPU, the system unit box or laptop, and then we'll talk a little bit of process address space, because everything, if you don't know understand about addresses of a process, you won't have deeper understanding of what's when you are talking about the in a program. So process address space, virtual memory is an important concept for everybody to understand, because let's say if you go for interview in any company, they will ask you some questions and you will get confused if you don't understand these basics. So we will cover the basics of process address space, and then one Python program, where we'll show you what is the difference between shallow copy and deep copy. This particular class is not designed to give you complete, I mean, in-depth, like not to cover a lot of topics of Python, just to give you an idea that how we'll be teaching. So I'll cover a few initial slides, and then Pradyuman, I'll give it to hand over to Pradyuman so he can cover us a few basics. So a few slides. So Pradyuman, can you go to next two slides? So bits and bytes. Bit is a unit, the smallest unit of where information can be stored. Smallest unit in the computer. It's either like computers understand the language of zero and ones. So that's why must have heard the digital. That digital is in digital world everything is zero and one. Zero is and zero state represents one state, and one state represents other state. So anything which has two states can be represented using a binary bit. States, it has two states, one and zero. For example, when torch is on, You can so you can say this bit, like bit one is being stored or being is being displayed. Bit one and off means zero. Go to next slide, Pradyuman. So a bit is the smallest unit, and 8 bits make a byte. And we start from like the world starts from bit, then byte, and sequence of bytes will make you the memory, right? So if you talk about any kind of memory, let's say hard disk or RAM, it is a sequence of bytes. You can just simply understand that it's a sequence of bytes, and every byte has an address. So first byte will be have address 0, then address 1, address 2. So this is the understanding you should have in your mind. The RAM or the hard disk or sort of a solid state drive SSD you have, it's just a sequence of bytes with these addresses. Go to next slide, Pradyaman. Yeah, this slide also I think it just repeats the that what bit is it, what byte is. Byte is like one in bit you can store one state, two states, 0 and 1, or anything which has two states. Byte, you if you want to store more complex data such as characters and like one if you one byte is 8 bits, and if you know permutation combination, you will see, you can guess that like we have 8 units where each unit can store two states, then 2 multiplied by 2 multiplied by 2 multiplied by 2. 2 raised to power 8 is the total number of states which can be we can store in one byte. And this is and then we want to store larger state like bigger information like a image or a video. I think that will require more number of bytes. So and like 1 byte generally to give you idea that 1 byte is good enough to store a character. So character is, let's say we have characters A, B, C. This character will have a ASCII code. You can read about ASCII code at the internet. It says ASCII code, and ASCII code can be is of we can be stored in 1 byte. So 1 byte is good enough to store a character. If you want to store more larger information, you store it in a uh, like larger number of bytes. Pradman, can you go to next slide, please? Yeah. So bits and bytes. So you should understand that how bits and bytes connect to the memory. Memory is just a sequence of bytes with its addresses. That is one thing you should keep in mind. Next thing you should keep in mind is about motherboard. Motherboard, oh sorry, the how the, what is in your in your CPU, and what is in your box. So a box, if you open up your CPU system unit, you will see a motherboard where you will have processor, and then slots where memory can go. So if you look at, there's a CPU socket in the center where your processor goes, and then there in the side way there are DIMM slots. DIMM slots are nothing but we call RAM slots, dual inline memory module slots. This is a technical term for RAM slots, where your random access memory goes. The main memory where where processor gets the data from to execute. Then a few other things. uh, I'll not cover everything here. I think if you have interested, we can explain. But important thing to note here is CPU slot, DIMM slots, and then there is a PCI Express slots and M2 slots and SATA. So SATA is where your hard in SSD SSD can be connected, hard disk drive, and on PCI Express slots you can put your sound cards or GPU, right? So this is, if you have this mental picture that this is how the motherboard actually looks like, then you will better understand that CPU, RAM, and then PCI Express slots and other slots where you can put your other cards, GPU and memory. Memory goes in DIMM slots, and then PCI Express slots. Mostly there'll be solid state drive and the GPU. So the like if you how you want to visualize your box, this is a chassis. It's a format is ATX. If you look at, generally we use ATX form. ATX is the form factor of the chassis. Inside that we have motherboard, on that we have processor, RAM. In the PCI Express slots we put GPU, and the M2 slots we put the SSD. So this will make your whole system. And this just the memory. RAM is also memory. Solid state drive is also memory. A random it's just bits of, it's a sequence of bytes, and GPU is to for displaying It's actually used for it's a graphics processor, and it is used to display a beautiful image on your screen. So because displaying an image requires a lot of power, it's a like where if you want to display a lot of pixels, if you use GPU, you will see better. If you assign this task to CPU, you will not feel, you will feel that there'll be some jitter, or you will not feel the good quality is good. So the good quality in the screen when you see it's because of GPU. Uh, can we go to next slide, Pradyuman? So CPU is the microprocessor. The technical term for CPU is microprocessor. It goes in the CPU slot. It's the brain of the computer, and yeah, central processing unit. Pradyuman, can you go back to previous slide? If somebody has any questions, we can pause for questions, because this is an important aspect. If somebody wants to know about anything, let me know. Any questions for anybody, please? Okay, if no questions, let's go. Let's move ahead. Go to next slide. We covered CPU. Then next slide we'll talk about the random access memory. Please go ahead. Next slide, please. So RAM, the main memory which goes in the DIMM slots, RAM slots, is the memory which CPU can work with. So this is the memory which is fast enough for which CPU can work with. Uh, uh, CPU cannot work with the, let's say, hard disk drive or SSD, because they are a lot slower than the RAM. And CPU, as CPU is becoming faster and faster, they need a faster memory to work with. So RAM is that memory where which is fast enough for CPU to work with. So all the data first, uh, let's say a program, when you write it, you store it, it is written in the hard disk or solid state drive. And then first has to come into the memory, the random access memory, and then CPU can access it. CPU does not access things directly from the hard disk. So RAM is the main memory where it's fast. It's why it's called random access memory, because in the RAM there are sequence of bytes, right? Everything, just RAM or hard disk, you just understand this is a sequence of bytes. So any byte in at any location, we have, let's generally say 4 GB RAM, 8 GB RAM, or 16 GB or 30 GB. Here, any any byte from that, uh, in the whole RAM, it'll take exactly same amount, same latency, same amount to access. CPU it'll take exactly same amount. It's not that if this byte is little far away down, below the, down below the address space, then it will take more. So this is the case with the hard disk, where hard disk we have magnetic disk. There's a magnetic disk. The head will move and go to that particular location and read it. It will take a little bit more time if it is far away. But random access memory, everything is exactly, it will take the same time. Randomly we can access any byte from the RAM, and it will take exactly the same time. And RAM has is temporary storage. If you turn off the CPU, the memory, this will be flushed out. Data will go away. When you turn on the system again, things slowly come to the RAM. First operating system will come, then more and more processor will come, and then the CPU will actually read from data from the RAM and execute them. Let's go to next slide. So this slide actually talks about little bit about how much how much RAM is sufficient for what kind of processing. So small RAM for basic browsing, word processing, 4 GB is good enough. If you do a little bit more multitasking, a little bit light gaming, then 8 GB is enough. 16 GB is recommended for most of the programmers nowadays. Any kind of work you do, if you, like all the work, if you want to use open multiple tabs in the browser, and so, or do little bit of video or some little bit of moderate gaming or programming. Like when you have to do heavy programming, then 16 GB is good enough. 32 GB is little, I would say it'll overkill for anybody who is not a serious gamer, or who is not doing really large editing. Let's say some engineers need to edit large design diagrams, and let's say design diagrams for big machines. They need a lot of memory. So 32 GB is good, is good for is what they will need. And other thing is like if you think about very large scale systems, like some systems where we need to do the really fast processing, some system you can assume that they can have even 100 GB of RAM or 160 or 200 GB of RAM, because like they need everything really fast. And such system do exist, like supercomputers and do exist where we have large amount of memory, but this typically on in a personal computer, this amount of memory is good enough. Let's go to the next slide, Pradyuman. Okay, let's talk about system bus a little bit. So this system bus, so in the motherboard you saw there's a CPU socket, CPU the socket where processor microprocessor goes and sits, and the RAM, and then the PCI Express slot where HDD and other cards will go. So system bus is where data and addresses will flow. So this is the connection between all different parts. So we'll have there are three lanes or buses in a total system bus. One is address bus, data bus, and control. So here to give you some idea. So as I said, RAM is a sequence of bytes. Now if CPU wants to access particular byte, so it will send the address of that byte on the address bus, and then it will put the, let's say there's a control, let's say there is a MWTC, memory write control, MRDC, memory read control, IO WC, IO write control, and IO read control. So if it's want to if the processor wants to read from the random access memory, it will light up that M read MRDC, memory read control, that particular line. It will say voltage 5. That means that it's lighting up voltage 5. It's bit 1. And I'll tell you what actually the bar means over, like, so when say MWTC, there's a bar over there, right? So here the voltage basically 0 means the bit 0 means it is active. So it be the two states. We can assume that the 0 can represent anything, 1 can represent anything. Here when this bit is 0, this MRDC line is 0, that means it's active. And MRDC, to make MRDC line active, it will be bit, it will say voltage 0 or bit 0, and that means the read write, we are reading from this memory. The address will go on the address bus data, and then once we address specific address, we need to pick the byte, and the data will go from the memory to the data bus to the microprocessor. So this is rough idea you should have as a programmer. I mean, as a, let's, if you really want to go into details, there are a lot of details to cover, but as a programmer, this is the idea we should have. So our aim is to give you enough detail to have a little bit deeper understanding when you're writing the programs, not impart a knowledge which really, good to know, but may not help you in programming. So you should have idea of the memory, how to think about a memory, and what are different types of buses. Can you go to the next page? Yeah, this just talks about how so I think this is the same thing. Basically, like we have a RAM as sequence of bytes, and control lines will say whether to read from the RAM or write from the RAM, and address will tell which byte to read, and the data bus will carry the data from or to the CPU. Let's say if you're writing it, then data will come from CPU to RAM, and be returned. And if it's read, the data will be picked up from the RAM and it'll go to the CPU. Next slide, please. Okay, before they like go proceeding further, do you have anybody has any questions? Am I going slow, going fast? Okay, so there's an option to, I think, say, I think raise your hand also in the Zoom. You can raise your hand, or if you want any questions, you can ask in the Slack channel also, the not Slack channel, the Zoom chat also, and we will try to answer those questions. And let me cover a few more slides. So hard disk drive and SSD. So we have two types of secondary storage. After RAM, there's a hard disk. So RAM is fastest, Slower than that is, let's say, secondary memory storage. That's a hard disk or solid state drive. Hard disk is little now getting, becoming older technology. SSD is the new technology. SSD is faster than hard disk drive, and SSD uses the same technology as your memory USB memory drive. It's a flash memory to store the data. You can say SSD is a large your USB memory stick with a huge lot amount of memory. And every type of memory, just think of from the programming aspect, is think of just the sequence of bytes. Okay, and that's the picture you should keep in your mind. And yeah, so you can read about these points, but ultimately SSD is faster, and it has a it's a the memory is a flash, which is same technology as a USB sticks, and it's faster. So SSD is preferred. It is costlier, so that's why not everybody is still not every like if you have the, let's say, same terabyte of, let's say, 1 terabyte or 2 terabytes of SSD, it will be costlier. But nowadays people, most of the times, they store things in the cloud. So around, I think, 256 GB, 256 MB or 512 MB or 1 GB should be good enough. That's how generally I think the trend is going towards. Now let's go to the next slide. So this gives you this idea about how the typical data movement happens. The first program is stored in the secondary storage. Then when it needs to be executed, first moves to RAM and CPU. Whenever uh, it needs to do its work, so it will pick up the instructions or data also from the RAM. And CPU also has its own memory, which are even faster than the RAM. Like it's called cache. So the L1 cache, L2 cache, and L3 cache, and some registers which are a lot faster than the RAM. So CPU first transfer the data from RAM to its registers and its cache, and then it actually really works with it. So CPU is really fast. Even if I said CPU can work with RAM, but CPU is even faster than RAM. It cannot directly work with the RAM. It first has to transfer the data to its registers, cache, then it works with it. So it picks up the data, does its work, and puts it back. So now I will let Pradyuman cover rest of the slides, and at the end, at the end, I'll just take over again to explain about our company and what we have to offer. Pradyuman, please go ahead.
Thank you, Sandesh.